And yesterday we got as far as drawing the diagram for question number 2. Okay, so let's just kind of quickly review the diagram for that as kind of a setup for what we're going to work on today. Okay, we're looking for the displacement of a soccer player who runs 15 meters at 15 degrees north of east and then 13 meters at 5 degrees west of north. What's going to happen with these questions is scale is going to become progressively more important on the diagram. Okay, so on this one, our first line is 15 meters long. Whoop, but that's not it because that's not how it goes. So let's try that again, Coder. Okay. It's 15 meters long. It's a skinny triangle. It's only 15 degrees. Okay, and it's 15 meters because apparently whoever made up that question likes 15. Okay, X and Y. The next vector goes tail to head on the first. Now the next vector is shorter and has a much smaller angle, and it's west of north. So at the end of class we were talking about this. How do I decide how that triangle should look? Okay, how do I make sure I draw the angle in the right place? The way you do that is you always look at the second direction that you're given of whatever. In this case it's of north. North is my reference. So what I do is I draw a line due north because it tells me I'm going to go 5 degrees west of that. This is west. And it's a super narrow triangle because the angle is only 5 degrees. Okay, and guys, just for the sake of significant digits, we're going to say that it's 5.0 degrees. Otherwise, we're going to get an answer with one significant digit, which I don't like. Okay, all right, so this will be our x, and this will be our y, and then our resultant goes from the initial position to the final position and has its own right angle triangle. This will be the vector of my total displacement. This will be the magnitude of my total displacement. This will be the y component and x component of the total displacement. Okay, so what we were working on yesterday was calculating vector components. So find x and y for the black and green triangles. Put them together to get purple x and purple y. Okay, give you a few minutes, see what we remember from yesterday. All right, so first thing we got to do is find all our x and y components. So we'll start with the black triangle. Okay, our x component for the black triangle is adjacent. It's touching the 15-degree angle, so that means we'll use cos. We'll go cos of 15 degrees times 15 meters, and we'll get that side. Cos of 15 times 15 is going to give us 14.489 meters, and that is east. All right, and then the y component is way over here, so it's opposite that 15-degree angle. So sine of 15 times 15, that'll be a much smaller side. Okay, so we're looking at 3.882 for that one. Meters, and that one is north. Okay, always important to put those directions on so that you know which ones are going to be positive and negative later. Then we got to do the same thing for the green triangle. Okay, so green x on the triangle there is actually the opposite side. So we'll go the sine of 5.0 times 13 meters. Okay, so that's going to be 1.133 meters, and that one points west. Okay, so this one will probably have to be negative when I interact it with the east. Right? The y component, okay, that is the adjacent side, so that'll be the cos of 5 degrees, okay, times 13, so that should be a pretty long side. Right? So cos of 5 times 13 degrees. And it gives us 12.951 meters, also north. So good news, the two y components both point the same direction, so I can just do what with the two of them? Just add them, right? They're gonna If we look at the diagram, black y plus green y is clearly the same as purple y. All right, so that's my next step, is I've got to take the x components, put them together, and take the y components and put them together. All right, so purple y then is going to be 3.882 plus 12.951, of course, with all the decimals that are in my calculator. All right, so that number plus the 3, that one there. All right, so 16.833 meters. And that's north. Okay, so now I know this side here is 16.833. Right, and then I've got to find purple x, but I'd go east and then I backtrack. Okay, so I'll go 14.489 plus negative 1.133, and just to make sure that I'm reflecting that west is backwards. Right, so I'll have that one, the 14, okay, plus negative 1.133. Okay, so 13.356 for that. Meters, and that is east, because I made east positive and my number came out positive. So 13.356. Okay, what's my next step?
Calculate the hypotenuse.
Right, calculate the hypotenuse here, okay? So that will be the magnitude of my displacement. So magnitude of the displacement is going to be the 16.8 squared plus the 13.3 squared. Again, I'm not writing all of the decimals in, I'm just showing that that's my next step in the method. Okay, so square root of that one squared plus that one squared. Okay, so total displacement there, 21.487. Meters. Okay, I don't have a direction on that yet because it's diagonal. I now have to calculate theta. Pick your favorite trig function. You have all three sides at this point. Right, for me, I'm going to go 10 to the minus 1. From this angle, my opposite side is x, my adjacent side is y, so that'll be the 13.3 divided by the 16.8. So second 10 of the 13.3 divided by 16.8. And that gives me 38.430. Degrees, which direction is my angle pointing?
East of north.
Yeah, east of north for me. Okay, now their answer here is 52 degrees north of east. Am I wrong? Come on. I'm not wrong. Okay, those angles are?
Opposite of each other.
Right, they're complementary. They both add up to 90, therefore they both point the same direction. Okay, and the same will be true for you. Because there's more than one way to draw this triangle, there's more than one vector that would be acceptable. They're the same vector, just from different points of view. One's east of north, the other's north of east. Okay, I just don't draw it this way, because for me, I hate drawing over my own lines. And it starts to get busy and confusing, and I just don't like it. Okay? All right, questions on that one? Okay. Try number 3. Scale is super important on number 3. All right, so here's why scale's important. I've got a line that's 300 meters south. Okay, that's the first thing this polar or wildlife biologist does. Incidentally, following a polar bear is a good way to get eaten by one. Okay. Did you guys see the video from that one that went through the town there in, I can't remember which, Churchill, I think, something like that, and this polar bear like went through town, everybody's like running away, and yeah, and there was a guy on a snowmobile, and it's crazy. They're scary. It's like a grizzly bear, but even angrier. Sorry, that was a total sidebar. Okay, now our second vector has to go on the head of the first, but it's 75 degrees north of east, and it's much longer than the 300. It's 550 meters. So I'm going to draw a line that's due east, but I'm not making it very long because this thing's going mostly up, mostly north, right? It's 75 degrees north of east. It's like this. Okay, here's where scale's important. A lot of people will just draw it so it's even with here and like, sweet, this is going to be so easy. Guys, it's never that easy. Okay, no one's ever going to be that kind in a vector addition question. Okay, so our triangle for that one, okay, is going to look like this. This will be the 75 degrees north of east, y and x, and then our resultant is going to go from here to there. Okay, I'm going to draw the triangle that way. I think they actually drew it this way in the question, but I'm drawing it this way just because I don't like to draw over my own stuff. Okay, so like I said, scale's pretty important. In fact, that probably could have been even a little longer. Like it's nearly twice as long, but I think it's still going to work out kind of the way I drew it there. Okay, it at least goes to where it's supposed to go, past the first one. Okay, so the rest of it, once the diagram is done, the rest of it works just like any other vector addition problem. Okay, for the purple line, it doesn't have an x component. It goes due south, so there's no x for the purple line. But its y component is 300 meters south. So obviously, a question like this would be out of less marks than the one we did previously. All right, and then for our red line, okay, x is going to be our adjacent side, so we'll have the cos of 75, so that's going to be a small number, okay, times, sorry, that was 550 meters long. Okay, so cos of 75 times 550. So that side is 142.350. Meters, and that is east. Okay, and then the y component is opposite, so it'll be the sine of 75. This will be the big side, 550. Okay, so we're looking at 531.259 meters north. Okay, so I got one that's north, I've got one that's south for my y components, and I only have one x component. So when I'm solving for the green triangle, my life's a little bit easier. Okay, I know that green x is the same as red x. This bottom side and that top side have to be equal. Okay, so that's just going to be 142.350 meters east. Okay, and then for the y, well, I've got a 300 meters south, so I'm going to go negative 300 plus 531.259. That's the amount I went north. That'll give me a positive number, meaning that yes, in fact, y is north. Okay, so negative 300 plus 531 there, okay, is 231.259. Meters north. Okay, so now I've got all of those. Now I've got the two sides of my resultant's triangle. So next step, same as always, do Pythagorean theorem to get the magnitude. 142 squared plus 231 squared with all the decimals in your calculator. That was close. Okay, 271.559. meters is the magnitude of that line, and I also need to get its direction. The way I drew it, x is opposite, y is adjacent, so that's going to be tan to the minus 1 of 142 divided by 231. Okay, so I'm looking at 31.6 degrees. But for me, that angle is east of north. Okay, they have the complementary angle, okay, and I haven't done my significant digits yet. Okay, so according to this one, that number has 3, that number has 3, but this number only has 2. So my answer can only have 2. Okay, so my final answer then will be the overall displacement of the wildlife biologist will be 2.7 times 10 to the 2 meters at 32 degrees east of north, or their answer at 58 degrees north of east. Okay? Everybody all right with that? Okay, so are we seeing that these are quite patterned? Right? Every one of these questions has the same 7 steps. I draw the diagram. I identify all the x's and y's. I calculate all the x's and y's. I add the x's together. I add the y's together. I get the Pythagorean theorem. I do trigonometry. I've got my answers. Always the same 7 steps. Now, is there a possibility I could kind of flip one of these and make you do those steps in a different order? It's possible. I could ask you, I could give you the resultant of this and ask you for one of the components or one of the parts of it. Then you'd have to go backwards. Okay? But you'd still have to find as many parts as you could and then do that. It's not as hard as it sounds, but we're not going to do that today. Okay?
Do the lines ever cross?
No. I mean, if you did 3, yes. But with 2 vectors, you should never have them cross. Yeah.
So it's 3 vectors.
Nope. We'll do some with 5.
Wow.
Yeah. Now, when you get to grade 12, you will very commonly have more than 2, especially in the first unit on conservation of momentum. So when you do collisions, okay, you'll have the initial momentum of each vehicle, and then after the collision, which way they go, you have to do a lot of solving for that kind of thing. Okay. Okay, try this one. It's harvesting time of year, so we got a combine question. I don't know, I guess it's not there. Okay, so first it moves 950 meters at 30 degrees north of west. Okay, so I'm going to start out with a north of west, but I'm going to start it kind of up here. Okay, and 30 degrees. Something like that. Jump into my words. Okay, let's just bring that down. Bring that down a little bit too. Okay, so this will be my 30-degree angle north of west. This will be 950 meters long. Okay, this will be y, and this will be x. Now, here's the trick. My next one is 385 meters, but it's 45 degrees south of east. Is scale really crucial here? Yeah, because it completely backtracks. Okay, so, well, not completely, but I mean, it goes back on itself. So for my next line, okay, I've got to draw a line that's east. Okay, if this angle is 30, so is this angle. Would you agree? Okay, so then this angle needs to be steeper if it's 45. Okay, and I'm going to make it quite a bit shorter. It's certainly less than half as long as my 950, right? 385 is less than half as long as 950. So this angle here, 45 degrees. Here's x, here's y, and here's my 385 meter long line. That means this diagram is a mess. Okay? Everything is going kind of over everything else. There's my resultant. not even really a place to draw that triangle without having to go over other things. Okay, so this angle here, okay, this will be y, and this will be x. That will be the total displacement, right? That's about as tricky as they can get in terms of the complexity of the diagram. Is the math any different? Now, what if, after I do my math, it doesn't agree with my diagram? Trust your math. Okay? Just double check both. Okay? But I've had times where I've drawn one and then I did the math. I'm like, ooh, wait a minute. That line's supposed to be longer than this other line. So I erase the diagram and I redraw it. Okay? As long as you're kind of policing your work a little bit, okay, in terms of does that match with that? Does that match with that? So that you don't have one of them telling you a different story than the other. All right? I'll give you a few more minutes on that before we go through the rest. Okay, so same process as always. I got to break this up into its x and y components. So let's start with the green triangle since that's where the question started. Okay, green x is right here adjacent to the 30-degree angle. So cos of 30 times 950 will give me what green x comes out to. All right, so cos of 30 times 950, 822.724. Meters west. Okay, and then the y component is the opposite side, so sine of 30 times 950 should be 475 meters north. Okay, everybody with me there? And then we got the black line, okay, and the black line is 45 degrees, so can that save me work? The line's 45 degrees, what does it tell me about x and y? They're the same number. Yeah, 45 degrees splits a triangle equally in half. If you went cos of 45 and then sine of 45, you did twice as much work as you needed to, but you'll catch on to that one because I'll do it again. Okay, you get a 45-degree angle, I'm giving you a freebie. Okay, so for this one, cos of 45, okay, times 385. And it gives me, as we just said, both my x and my y. Cos 45, okay, times 385. Okay, 272.236. Okay, meters, and that is east. And then for y, okay, we don't have to write this one. Okay, sine of 45 times 385. So we have to write it, but we don't have to do it. Okay, because it's the same number, 272.236, but this time it's meters south. Okay, so everything backtracks. My x components are east and west. My y components are north and south. So I have to keep that in mind when I'm looking for blue x and blue y. Okay, so to calculate blue x, west is usually negative, so I'm going to go negative 822.724 plus, okay, 272.236. That's going to get me a negative number. That's fine. I know that means west. Okay, so 822 right there. Okay, 822. Okay, and I'm just going to put minus in my calculator because that's the way it's going to work out. All right, so I'm going to get 550.488 meters west. Okay, and then for my y's, north is usually positive, so 475 minus, plus negative 272.236. Okay, so 475 minus, plus negative 272. Okay, so 202.764 meters, and that is north. Now, when I get to this point, what I like to do is I like to check my triangle and make sure that those numbers make sense. Okay, this line's 550 meters long. Yep, okay, that's about right. Okay, it's about half of this one, so okay, I can live with that. Okay, and then for my y, it's 202. Yeah, I can live with that because this y was 475. It looks like my diagram's pretty close, okay? There's nothing really glaring there. And now I can move on to calculating the magnitude of my total displacement. So that'll be the 550 squared plus the 202 squared, obviously keeping all the decimals. Okay, so my total displacement's 586.643 meters. Don't know what the vector is on that because I still have to calculate that. The way I drew my triangle, okay, you could have drawn yours the other way, totally fine. Y is opposite of x. Okay, so I'll go tan to the -1 of the 202 and divide that by the 550. Second tan of the 202 divided by the 550. Okay, so I got 20.22 degrees. And for me, that is north of, which way is this? West. Now, how many significant digits can my answer have? The angles count, right? Did I use the angles to calculate things? Angles are measured values, angles count. Okay, so I can only have 2 significant digits in my answer. So that's going to make this number here 5.9 times 10 to the 2 meters at 20 degrees north of west, or at 70 degrees west of north, depending on which way you drew the triangle. Okay, how are we feeling about that?
I did 350.
That probably got you the wrong answer somewhere along the way.
Yeah.
But if your method was right along the way, you'd still get some part marks for that. Okay, that happens. I do that sometimes too. I'm like, I just get a number in my head and it's the wrong number, but I keep going with it. Nobody says anything because they're afraid to tell me I'm screwing up, which you should not be. Okay. All right. What time we got here? Let's give you about a 3 or 4 minute break here before I put one more up. Okay, guys. I'm going to give you one here. This would be an exam level question. The one we just did isn't. Okay? On an exam, I just want to know, can you follow the rules for vector addition? Can you draw a reasonable diagram? I don't need to give you a 5 vector that all go back on each other question, okay, to find that out. So more than likely, I would give you a question that would be like C here. One of the vectors would be along a compass direction, and the other one would be angled. Okay? It could be like this one, or it could go back on itself a little bit. Okay? But know that I would want it to not take a really long time on a test. Just be able to demonstrate to me, hey, I can calculate X and Y components, I know how to put them together, okay? But I didn't have to do 10 marks worth of stuff, I only had to do 7 or 8 marks worth of stuff. Just makes it a little shorter. Okay, so C would be an exam level question. All right, give C a try. I'll give you a few minutes to get the diagram done, then I'll draw it. Okay, give you some more time to finish it. Okay, so we got 8 meters east. Okay, so no triangle for that one because it goes right along an axis. Okay, and then we've got 6 meters at 35 degrees north of east. Okay, so there's due east, 35 degrees. Okay, 6.5 meters, or sorry, not 6.5, 6.0. Okay, 6.0 meters. Yeah, I'd say that's the scale's probably good enough on that. X and Y, and then our resultant go like that. You could draw the triangle this way or along your other lines, whichever makes the most sense to you. Should look like that. So for our first line, for the blue line, obviously there's no Y component, okay? It simply goes 8.0 meters east, okay? It does not go north or south. Okay, then we've got the green triangle. X is adjacent, so X will be the cos of 35 degrees. Okay, and we'll be multiplying that by 6 meters, the hypotenuse of that triangle. Okay, so cos of 35 times 6 gives us 4.915 meters east. So that's nice. Both x's go east. Okay, and for y, okay, sorry, we'll be using the sine because it's the opposite side. Sine of 35 times 6. Okay, and so that's going to give us 3.441 meters, and that one's north. Okay, now that we have those, now we can work on the red vector. Okay, for red x, that's going to be 8 plus the 4.915, so that'll give us like 12.915. Okay, but I'll put that in the calculator just so that we have it. Okay, so we've got that one. And then we have to get, for our y, we don't have to do anything because this y and that y are equal. Okay, so y will be 3.441. Okay, sorry, this is meters east. Okay, and this will be meters north. All right, now that I've got those, now I can find the magnitude of d with the Pythagorean theorem. So the 12.9 squared plus the 3.4 squared. Okay, that's squared plus that squared. Okay, gives me 13.366 meters. And we want to get theta there, so second tan for me, x is over y. Okay, so that'll be the 12.91 divided by the 3.44. Okay, and I'm getting 75.08 degrees, and for me, that is east of north. Okay, how many significant digits can my answer have? 2, because that's all I was given, right? 2, 2, and 2. Okay, so my answer would end up being 13 meters at 75 degrees east of north, or 15 degrees north of east, depending on how you drew it. All right, so on a unit exam, I mean, you could get one like that where they're in the same direction, or maybe I could go like down and up or something like that, but you're going to get one that's going to be along a major axis and one that's angled. You just have to demonstrate, hey, Claire, I know how to resolve a vector into its components. I know how to put them together. Okay? I know how to do Pythagoras and trig, get an answer, and do significant digits. Okay? Are we going to do ones that are trickier than that? Yes, we are. Okay? Absolutely. But we need to, because when we get to projectile motion, we've got to be able to do all the same things. Okay? Find vector components and stuff like that.
So the 5 ones just practice pretty much like this?
The what?
You said there's 5 vectors, that one's just...
Yeah, I can just give you one for fun.
Okay.
Fun. In air quotes. Yeah, just to challenge you a little bit. It's more about the drawing of the diagram. Like
Yeah.
how well can you really keep all of that stuff straight? It's more about that. Okay, guys, I think we'll call it there. The Angelus will probably come on here in a minute. So tomorrow, we'll probably keep doing more of this. Quiz on Friday, okay, we're going to have some vector stuff and some acceleration stuff on it, okay? So you might want to start looking at those practice quizzes. You can do all of those now, okay? And just kind of see how things are going with that. Next week, we'll probably start out with an activity using a map, okay, where we got to do a little vector stuff, but not sitting and doing a problem from your sheet for an entire period. You can work with a group and do some map stuff instead.